All right, we are working, if you're watching the video that I just started, we are working exercise 3 where we left off to review our conditional statements. So I'm going to push pause on the video. So if you're watching, go ahead and do the same and do the problem. All right, just about another minute. Do as much work as you can. I know that maybe you didn't get all the way done. That's okay. Work at your pace. Just so that we're all starting the same page, what would you suggest is the first thing that we do for this problem? Yeah, we've got this parentheses we have to deal with. The squiggly P, then Q. That's the conditional statement. And before I can do the conditional statement, I need a squiggly P. So if you're sitting there and you're befuddled and wondering where to start, that is where to start. Do a column for squiggly P. And then do a column for the parentheses. So just in the effort to help you review, okay, because we have a test coming up fairly soon. I think, I don't know if it's next week or the beginning of the week after, but it's rushing right at us. Remind me, what does the negation do to the truth value of my statement? Just makes it the opposite. Well said. Perfect. So I'm going to go down the P column. I'm just going to make everything the opposite. So instead of 4 trues and 4 falses, I'm going to reverse that to 4 falses and 4 trues. Now, the conditional statement is what we just began, and I mentioned to you when we went over the basic facts, which you could have flipped back to your front page to see, that the conditional statement is the only one of the 5 connectives that the order matters. So to remind myself, because I would goof this up, I guarantee it, I am going to draw the arrow that goes from the squiggly P to the Q column so that I know what order I'm looking at my columns in. And please remind me, in my conditional statement, what is the one time? There's one time the conditional statement is false. And when is that? True, then false. Remember, that's when you met the condition. It's true. You got the 95, but then you did not get the consequence. That was false. And so the conditional statement did not act like it should have. You did not get what you were supposed to. So any other situation is true. We're just looking for the trues then falses. So here we go. Going from the squiggly P to Q. I've got false, then true. Well, anytime false comes first, what's the net result? True. Yes, that's the goofy one. And just to remind you, the reason for that is when the condition is false, For a conditional statement, that means that you didn't meet the condition, so you have no expectation of the consequence, either positively or negatively. Doesn't matter. And that is why logically the conditional statement is doing what it's supposed to. It's true. Okay, so again, I've got false, then true. So that's another true. False, then false, another true. False, then false. That's another true. Then I have true, then true. This is, you've got the 95, you got the consequence, you got the A. That's true. You got the 95, you got the A, true, then true. And here's the last two that we had our eyes peeled for. True, then false. That is the false statement. True, then false. That's the false statement. Now what I'm going to do is I'm going to take that parentheses that we just did, that column that we just finished up was the parentheses, and I'm going to and it. I'm going to use the conjunction with R. So I'm going to put a little check mark over my P, if P, then Q, and over my R column, just so I know which columns I'm using. Again, remind me, my conjunction, my and statement, when is the and statement true? Both have to be true. That's the only time. So I'm just going to go down here. And so row 1, I've got true and true. So that's true. You guys are right. Great job. False and true. Yep. True and true. False and true. True and true. Yep, you're doing great. Thank you so much for helping. False and true. True and false. And false and false. Perfect. So when you went through this, the first, the third, and the fifth row should all be true. The other ones are not. Any questions remembering the conditional statement? That's about where we left off. So again, the purpose of this chapter, one of the purposes, in addition to being an introduction to logic, is trying to help us all understand what makes an argument valid. So part of that process is starting off with the words, then going to symbols, and then we're going to talk about that when we come back next week. Here's what I would like you to do. We're going to link what we're doing now together with something we did in section 1. We did this in section 3.2 with a conjunction statement. I've given you this statement right here. If you use top power, comma, then you will not feel tired and you will get a solid workout. So we're going to do this. There's 3 steps to this problem. We're going to do this in phases together. What I would like you to do is make your best effort at step 1. Define the 3 simple statements. And I'm just going to give you a little hint. We always define simple statements without a negation. Okay, always positively. I'm just going to read the statement from left to right, and I'm going to write down the simple statements in the order that I see them. This part of the problem, if you defined the simple statements in a different order than I did, that's okay. Okay, it doesn't affect really anything. So here goes. If you use top power, so my statement P is going to be you use top power, whatever top power is. Then you will not feel tired. So statement Q is you will feel tired, which we would not want, I guess. And then the last one is you will get a solid workout. So please notice for statement Q, I left out the word not. We always add the negations back in symbolically when we write this symbolically, which is your next step. So if you have a question at all, please, you're never an interruption to me. Okay, so just wave your hand. You might need to wave it because I'm not wearing my glasses. Y'all just look really blurry right now. But I am here for you. Okay, so please let me know. I know this is weird, confusing stuff. So next thing I'd like you to do off on the side is I'd like you to take that statement that's in words and now write it symbolically. So two things I want to notice right off the top, okay, is the first thing is this statement starts with the word if. If means a conditional statement. So if means I need to draw an arrow. The second thing I want you to notice is there's a comma in this statement. What do commas tell me when I am reading? Parentheses, there's grouping. Okay, so looking to the left of the comma, how many statements do I have to the left of the comma? Okay, there's going to be one statement on the left of the arrow. And then to the right of the comma, how many statements do I have to the right of the comma? Two, that's where I'm going to do my parentheses. Okay, so to the left of the comma, I have you used top power. So that is statement P over here on the left. On the right, I'm going to have my parentheses because I see that comma there. So then you will not feel tired. So that's squiggly Q. I'm putting the negation back in. The word and is the conjunction. So I'll do a caret. And then you will get a solid workout. That is just statement R. Any questions about that? That can be a tough thing, especially when you got three statements and you got a comma, all sorts of stuff to look for. All right, the last thing I'm going to give you a couple minutes to get a good start on is now do the truth table for that statement. That's the last step that we are going to involve ourselves in up to this point right here. All right, I'm going to get started. Keep working if you're still working. Not trying to rush you, just trying to make sure I'm splitting the difference between people who are done and people who are still working. So once again, I'm going to start inside the parentheses. And so I'm going to start with that negation. So squiggly Q. And I'm not going to ask you again because you just informed me that the negation changes my truth values. So I'm just going to go down the Q column and it's going to become false, false, true, true, false, false, true, true. If at any point I do something that confounds you, let me know. I'm just going to keep working. I don't want to bore you, but I also don't want to ignore you if you have something you need. So again, finishing up the parentheses, I've got the squiggly Q and R. And again, you already answered this for me, so I'm not going to ask it again. The conjunction, the and statement is true when both are true. So I'm going to put a little dot over my squiggly Q and my R column just so I know what I'm dealing with here. So here goes. I've got true and false. Row 1's false. False and false. Row 2 is false. True and true. Row 3 is true. Row 4 is going to be false. Row 5 is false. Row 6 is false. Row 7 is true. And row 8 is false. Up till now, anybody got anything different? Because I got one more column to go. We're just about done with this problem. The last one now is to link those two things together. I'm going to link column P with the column that I just made. I'm going to put my arrow right here just so I remember my order and I don't get confused because I easily get confused. And so now I'm going to go down the rows. You're going to help me here because this is our new stuff for the day. So the first row is true then false. What's that? That is great. And then true then false again is false. True, then true. What is the third row? True, then false. Once again, great. And then all the last ones all start with an F. Okay, it doesn't matter what the consequence is. When you start with the false, your conditional statement is true. And there we go. There is my result. All right, before we do the other, there's one more basic truth fact we have, and then you know all the basic truth facts, and the next couple sections is just going to be using these facts. Okay, so if you have a question, but we're going to now turn our attention to the last of them, the biconditional. So the biconditional, remember the biconditional I told you when we talked about it is basically two conditional statements in one. That's why we use a double arrow to signify it. So basically what this is saying is if I read this statement from left to right, what this is saying is I've got P then Q. And then it's saying if I read the statement backwards from that would be right to left, then I have if Q then P. Okay, so that's all a biconditional means is you've got both of these things that have been joined together all in one statement. So we're going to use that. We're going to use our knowledge that we have now of the conditional statement to come up with the truth table for the biconditional. And like I said before, the conditional is the only one order matters. As we go through this table, you'll see why I say for the biconditional, order is not going to matter. So here we go. Let's do this one at a time. So let's say that I read this from left to right. I go from P to Q. I go true, then true. What's the result of that statement when I go true, then true? True. Now I'm going to go backwards. I'm going to read the statement from right to left. So I'm going true, then true again. And so what's the net result of that? True again. So both ways, no matter which way I go, I get a true. So that means this is true. The biconditional is true. I'm going to skip the middle two. We're going to go down to the bottom. The bottom, they're both falses. So again, when I read this from left to right, I go false, then false. P then Q is false, then false. So that would be what? For my conditional statement, false, then false is true. Okay, that's true. And then when I read backwards, when I go from right to left, I go false, then false again. False, then false. That is what? True. So either way I go, either direction I go with my conditional statement, I get a true statement. So the biconditional is true. Now I'm going to go back to the second row. The second row, when I read this from left to right, I go true, then false. What is true, then false in my conditional statement? That's false. That's the false one. I'm going to stop there. I don't even need to turn around and go the other direction. Since it's false going from left to right, that makes the whole statement false. And then last but not least, I've got the false then true row. So when I read this from left to right, P then Q, I get false then true. So false then true, that is true. So I'm so far so good. But now what happens when I turn it around and I look backwards, when I go right to left? I've now got what? True then false. And true then false, we know that's the bad order for the conditional statement. So because when I turn it around and I read this from right to left and it's false, my biconditional is false. So all that is the long-winded way to say, when is the biconditional true? Looking at that, how would you summarize? When both are the same value. Yes, when they're both either true or both either false. That is when the biconditional is true. When either one of them is false, okay, when you have one false and one true, the biconditional is false. Okay, so finding a way to make sure you remember these when you go to take your test, that's the most important thing. What I would recommend when you take your test, whenever that day is, of course, I'm hoping you're practicing this. We will, at the beginning of next class, we'll practice these, but I would do a brain dump. On your scratch paper that I give you, I would real quick draw out the 5 basic truth table facts. And that way, you know them, you've got them written down, and you can go about your business. Okay, so that would be my recommendation when you take the test. Okay, so I've just got a couple of examples for us. So I'm gonna let you do this. This is exercise 5. We've just got 2 problems we're gonna do that demonstrate the biconditional. Or maybe more than 2. All right, once again, I'm going to get started. If you're working, keep working. There's nothing wrong with you. You're not supposed to be done. Everybody works at their own pace. Okay, so first thing again, these parentheses are drawing my attention. So I'm going to start with a squiggly P on this particular problem. Okay, we've already reviewed this a few times. So hopefully for the squiggly P, you just negated the whole P column. So 4 falses and 4 trues. And now I am on my way. The parentheses contain a conjunction, an and statement. So I'm going to take the squiggly P. I'm going to and it with R. So I'm just going to put a little dot over those 2 columns. Once again, it's a conjunction. So those are true when both are true. So the first row, true or true and false is false. False and false is false. True and false, false, false and false. Lots of falses. We've got true and true here finally. False and true, true and true, and then false and true. And then last but not least, I've got my biconditional with column Q. So I'm just going to put a check mark. I've got column Q right here. I've got the parenthesis column right here and the biconditional. So again, I'm just having you repeat something we said a moment ago to hopefully get things from short-term memory into long-term. When is the biconditional true? When both values are the same. Well said. Perfect. Both values are the same. So here we go. I've got true if and only if false. Not the same. True if and only if false. Not the same. False if and only if false, both the same. False if and only if false, same. True if and only if true. True if and only if false, those are not the same. False if and only if true, not the same. And then false if and only if false, those are the same. So there we go. Seem reasonable? All right, we're almost done with this section. You're doing a great job. I appreciate your endurance and your patience. Okay, so we just have another example like we did a few minutes ago with our conditional statement. So I'm just going to, let's do this in phases, just in case there's any questions along the way. So step 1, I'm going to give you 30 seconds or so. Go ahead and define your 3 simple statements. So the statement that we're doing is if the dam holds, then we can go fishing. And notice there's a comma, if and only if the pole is not broken. So statement P is the dam holds, which we would hope happens. Then statement Q, we can go fishing. And then finally statement R, the pole is broken. Took the negation out. Oops. Broken. I'm going to give you another 30 seconds. Maybe you've already done this. Maybe you're already onto the truth table. That's fine. But another 30 seconds. Write the statement symbolically. Okay, so again, this starts off with the word if. So if means I have a conditional statement, so I'm going to draw an arrow. Here's what we notice this time. Again, we have a comma. How many statements do I have to the left of the comma? 2. In fact, the whole if-then statement is on the left of the comma, that whole arrow. Okay, so I'm going to put my parentheses around the if-then statement. So it says if the dam holds, so that is statement P. Then we can go fishing, so P, then Q. Then my comma, the comma tells me all of that is in parentheses because it's all on the same side of the comma. And then I have the word if and only if, or I guess that's words is the proper way to say that. I have the words if and only if, so that is a biconditional statement. And then the pole is not broken, so that is squiggly R. I'm going to give you another 90 seconds, 2 minutes to make as much progress on the truth table as you can. If you have any question about why the parentheses are where they are or what's going on, please don't be shy. So I need to do 2 columns to start off with, the column for each of the things that surrounds the biconditional. So in the parentheses, I've got a conditional statement, if P, then Q. So I'm going to put a little arrow right above the P and the Q column. And I'm going to go through that. You've answered this question for me a bunch of times, so I won't make you do it again. The conditional statement is false only one time, when you have true then false. All the other times is true. So true then true, true then true. The next 2 are true then false. Then I have false then true, false then true, false then false, false then false. Anytime we start with the false, the entire statement is true. Squiggly R changes the truth value of my R column, so it becomes false, true, false, true, false, true, false, true. And then while I write this down one more time, please just indulge me. I'm not doing this to torture you. So last time I'll ask you, when is the biconditional true? Both are the same. Yes, exactly right. So these are my 2 columns. When they both have the same value, the biconditional is true. When they have different values, the biconditional is false. So true if and only if, false, that is different values. True, true, those are same values. False, false, same values. False, true, different values. True, false, different. True, true, same. True, false, different. True, true, same. There we go. All right, so that's the 5 basic truth values. Got one more little blurb for you, and then we are done with this section. So we'll flip the page one more time. What we see on this page is going to prepare us for not the very next section, but the section afterward that we will get to on Monday next week, when we finally, at long last, get to the point of being able to look at arguments and determining their validity or not. So in order to determine their validity, we have to look for something. So here's a couple things to distinguish between a compound statement that is always false. So when you look at the last column, when you are done, all that there are F's. Okay, when you have something that is false, that would be something that would be called a self-contradiction. Yes. Yes, a compound statement is everything we've been dealing with. When you link two or more simple statements together, it becomes a compound statement. And a simple statement is something that expresses a single idea. So on the previous page, this problem right here, this thing that we wrote symbolically, that is a compound statement that has been joined together with connectives. In order to do that problem, we broke it down into three simple statements that are joined together. That's the difference. Okay, you with me? Awesome. See, love questions. Ask a question. I will do my best to answer it, or we will figure it out together. Awesome. Okay, so a compound statement that is always false is a self-contradiction. So if you've ever used the phrase that somebody contradicts themselves, that means that the thing that they have said is false under any circumstances. Okay, that doesn't make any sense. Okay, then you can have just the flip side of that is something called a tautology, Tautology. It's fun to spell and say. Okay, a tautology, that is a compound statement that is always true. So that when you look at the last column of that compound statement, there's nothing but T's. Now, tautologies are great. And when we go to do arguments, arguments are going to be conditional statements. We're going to make our argument in the form of a conditional statement. So there is a special type or a specific type of tautology. So a specific type of tautology that is a conditional statement, this is called an implication. So an implication is also a tautology. It's always true, but it's a special kind. It's more specific. It's a more specific category. It is a tautology that comes from a conditional statement. So if you have a tautology that comes from a conjunction or a disjunction or a biconditional, they don't get a special name. But if you have a tautology that comes from a conditional statement, that's called an implication. So if you've ever used the word implies, if you've ever said this situation implies this, then what you are saying is it's true under any circumstances. And that's what we are going to get to when we look at arguments. So the last exercise for this section is a relatively simple one. I've given you this statement here that has two simple statements. And I just want to know, I'm going to cross out tautology because it's a conditional statement. So if it's a tautology, it's an implication. So it's either going to be a self-contradiction or an implication. One of those two, or neither. If there's a mixture of truths and falses, it's neither of those things. Okay, so go ahead and do the truth table and we'll see what we get. All right, so going through this truth table, this one's kind of just a short one. There's only two columns necessary for it. The first column is P or Q. This is good because I have not asked you this question today. This is the first disjunction we've done. So last review question for the day. When is the disjunction? When is the or statement true? When either one's true. Yeah, as long as you see a T there, It's true. So we've got true or true. So that is a true statement. True or false. That's a true statement. False or true. That's a true statement. Then finally false or false. That's false. So then the last thing we've got is we're going to take statement P. We're going to do that with my parentheses. So here's statement P, here's my parentheses. We're going in this order. So again, the conditional statement is false only one time when you have true then false. So here we go. True then true, that's true. True then true, that's true. False then true, that's true. False then false, that's true. And what we have here, this is called an implication. So my last column is all trues. That makes it a tautology. But then again, because this is a conditional statement, because of that arrow, it is a specific type of tautology, which is an implication. And that's that. That's that section. What's up, Roberto?